Good morning to everyone. So today in the second lecture, we are going to start with the integral calculus. So in that integral calculus, specifically, we are going to take, that is, double integration first, and next triple integration and change of order. So now, in the beginning, so while starting with the double integration, first we need to understand what is the function f of x comma y. That is, f of x comma y means what? It's a function which depends on two independent variables. One is x, another one is y. So therefore, whatever the function that f of x comma y we are taking, so this will create a surface. So therefore, so by taking this surface, so we are going to find, that is double integration. That is double integration. So what we are explaining on the function f of x comma y, so which will be having two limits. One is along x-axis, other one is along y-axis. So that here you can see, here it is x-axis, here it is y-axis, here it is origin, that is O, we can say. So now here there is a what, the area. So it will be like this. So we have this area. So now you can see the limits. So here this is one limit and this is another limits along x-axis. So this is x-axis. So therefore we can say this is x equals to A, this point is, and this point is x is equals to B. That means two extreme points we have taken along x-axis. And now in the same way, so what we are doing in a double integration is, so we are allocating, that is, two integrations. One is taking a limit along x-axis, another one is taking a limit along y-axis. So now taking a limits along y-axis, how one can take? So now you can see here, so here you can make a bifurcation like this. Okay, so here there is a one curve, so which I'll be writing. There is a one curve, so this curve is there. Okay, so this we can call y is equals to, that is, y1 of x, because here this is a curve, it's not a straight line, so that we can allot the constant. So therefore here we can say that y is equals to y1 of x. This is this curve from this particular point to this particular point. That means this is the curve, that is y is equals to y1 of x. Similarly, so one more we can allot. That means here from this particular point to up to here, there is one more, that's what, curve, that we can call y is equals to, that is y1 of y is equals to, that is y2 of x, we can say. So now we can see, guys, here we have allocated the limits along x-axis, that is from x equals to A to x equals to B, and we have also allocated the limits along y-axis, that is, one is from y is equals to y1 of x, from y is equals to y1 of x to y is equals to y2 of x. So therefore, then how one can write the definition of what that is double integration. So here we can see, here I'll write the definition. You can write the integral of f of x comma y, the integral of f of x comma y over a region, over the area A, is denoted by integration over a area A, f of x comma y dx dy, or else we can say that is dA also. First we can say dA, that is dA, and defined by integration over a area A, f of x comma y dA is equal to, in double integration, okay, for both the integrations we have to allocate, that is limits. So here I'll write x equals to A to x equals to B, and here I'll write y is equals to y1 of x to y is equals to, that is y2 of x f of x comma y. Here the second integration is with respect to y, so therefore first you have to write here, that is dy, and here you can write that is dx. So this we can call that is double integration. Okay, so now we can call it equation number 1. Okay, it is called that is double integration. It is called double integration. Okay, so you can see now here x equals to a to x equals to b means what? That is limit from x equals to this point to up to this point along x axis, and y is from y1 of x to y is equals to y2 of x means what? That is limit from this lower curve to, that is this upper curve. So therefore y is equals to y1 of x to y is equals to y2 of x. This is one way of writing, that's what double integration. Similarly, we can write in one more form also. That is similarly we can write in the following similarly we can write in the following form, that is integration over a region a f of x comma y, that is dA is equals to integration, that is double integration I'll write, and now I'll interchange, that's what these limits. That means first I'll write y, that means y is equals to something constant c to y is equals to some constant d, and x equals to something x1 of y2, that is x equals to x2 of y f of x comma y into dx into dy. I'll explain this by using that is the graph. You can very easily understand. So how I have taken y is equals to c to y is equals to d, and x equals to x1 of y to x equals to x2 of y f of x comma y dx dy. You can compare these two. Here dy dx is there, here dx dy is there. That means if you interchange dx dy, then limits will get changed. Then now you can see here I'll draw the diagram for that. This is x, this is y, here it is origin. Now again the same diagram I'll draw. Yes, so now in the beginning case, so we have taken extreme what the points along x axis, but now what we'll do, we'll take extreme points along, that is y axis. So this is one extreme point, that is here you can say y is equals to something c we can say, and this is another extreme point, that is y is equals to d we can say. Okay, so now here you have these 2 points, okay, and just to bifurcate it, now here we have this one curve. You can say this one curve which will be from here to here, okay, and this curve will be calling as, that is, see guys, here along x axis we are doing, that means what, this is a lower curve and this is the higher curve. That means what, this is the lowest, that means what, least value of x, so this curve is there, and for highest value of x, so this curve is there. So therefore we can call it as what, that is x is equals to x1 of y. Okay, in the similar way, here from this particular point to this particular point, this curve will come. So this curve will come. So now we can call it as what, that is x is equals to x2 of y. Okay, so that means what, from first beginning you can see here y is equals to c to d. That means what, along y axis y is equals to c to y is equals to d, and along x axis, that is this curve, that is x equals to x1 of y to x is equals to x2 of y f of x comma y dx dy. Okay, we have so these two are the similar what the definitions. Okay, and equation 1 and 2 both are same. Okay, they are not different, they'll yield the same answer if you use any one of them. Okay, so now we shall start with the examples. Okay, we shall see examples on this double integration. So now here I have one example. Examples. First one, evaluate integration 0 to a integration 0 to y by a e to the power x by y into that is into dx into dy. Okay, this is the first example we have. So now we shall solve this particular example. Okay, so the solution, first write what they have given. Let I is equals to integration 0 to a integration 0 to y by a e to the power x by y dx dy. Okay, dx dy. That means how we'll write this? That is I is equals to, actually here the variables are not allocated. Okay, so whether this is x equals to a or y is equals to a to y is equals to a, so what is that they have given? You can see here, we can consider this. So here dx is there, that means what? This will be for this one. That means what? X is there means what? This should be with respect to x. And lastly here y is there, dy is there, so therefore this will be with respect to, that is y. So that only I'll write, that is y is equals to 0 to y is equals to a. Here you can write x equals to 0 to x equals to y by a e to the power x by y. This is dx, this is dy. Now you can call it equation number 1. You can see this we can call f of x comma y. Okay, this generates a surface, and these boundaries y is equals to 0 to y is equals to a and x equals to 0 to x equals to y by a yields, that is volume of this particular function with these limits. Okay, these limits, so it will yield that is volume. And if at all this e to the power x by y, if it is not there, and here you get only here you get 1 instead of what this you get only 1, then that yields the area. Okay, area bounded by, that is what, y is equals to 0 to y is equals to a, x equals to 0 to x equals to y by a, whatever the area is there, that area it will finds. But here f of x comma y is there, so therefore it will not find the area, it finds, that is volume of this particular surface bounded by these limits. Okay, so now we'll start solving this particular example. That is I is equals to integration y is equals to 0 to y is equals to a, and here you can see, here with respect to x we need to integrate. That means what? Whatever e to the power x by y is there, in that e to the power 1 by y whatever there, so that will be 1 by y will be, that is constant. So only with respect to x we are differentiating, integrating. Therefore e to the power x by y we have to keep first as it is. Next we need to divide it by what? That is constant. What is the constant here? 1 by y is the constant. So therefore here you can write, that is 1 by y, and limits are from x equals to 0 to, that is x equals to y by a, and here it is dy. Okay, so now I'll rewrite it. I is equals to integration y is equals to 0 to y is equals to a. So this y will comes in the numerator. So therefore e to the power x by y. So therefore limits are from x equals to 0 to x equals to y by a into dy. Okay, so now which implies that I is equals to, now put upper and lower limits. That means wherever x is there you have to write y by a, and wherever for a lower limit wherever x is there you have to write 0. So here we'll get integration from y is equals to 0 to y is equals to, that is a, and now y into e to the power x value is y by a, so therefore y by a divided by, that is y, minus, for this is upper limit, and for the lower limit if you put x equals to 0 then e to the power 0 will get, e to the power 0 value is 1, so y into 1 is, that is y into, that is dy. Okay, so which implies that I is equals to, now you have to integrate this with respect to, that is y. Instead of that, first you simplify it. Y is equals to 0 to y is equals to a, this y get cancels, here you will get y into e to the power 1 by a minus y into dy. So now I is equals to e to the power 1 by a is a constant, so you can keep it outside, and integration of y with respect to y is y square by 2. So therefore y square e to the power 1 by a divided by 2 minus y square by 2, and limits are from y is equals to 0 to y is equals to a. So which implies that I is equals to put y is equals to a, that means a square e to the power 1 by a divided by 2 minus a square divided by 2, for this is for upper limit, and for lower limit both will be, that is, zeros. So therefore 0 minus 0 we can write, which implies that I is equals to, that is, a square by 2 we can take common, a square by 2 we have taken common because in both the terms a square by 2 is there, and here you will get e to the power 1 by a minus 1. So this is the final answer of that is first example, that is a square by 2 in the bracket e to the power 1 by a minus 1. So is the answer of first example. Okay, similarly we can solve many examples, as many as examples you want. So therefore, so now I'll take up next example, that is okay. So next example here we have is evaluate example number 2. Example number 2, evaluate integration from 0 to 1, integration from x to root x, x square plus y square into dy into dx, into dy into dx. Okay, so now solution for this particular example is, let again write the same thing, I is equals to integration from 0 to 1, and here it is integration from 0 to x to root x, here x square plus y square, this is dy dx. Okay, so this x square plus y square is what, that is f of x comma y. So now write the variables. Okay, so I told you, so this is here dy is that means what, the second integral is with respect to what, that is y, so therefore y is equals to x2, y is equals to root x, and this is x, so therefore this will be x equals to 0 to x equals to 1. So write that x equals to 0 to x equals to 1, y is equals to x2, y is equals to root x, here it is x square plus y square into dy into dx, call it equation number 1. So now I is equals to, first integral we have to keep as it is, x equals to 0 to x equals to 1, integration from x equals to 0 to x equals to 1 you have to keep as it is. Now integrate this x square plus y square with respect to, that is y. Okay, so with respect to y if you integrate, then x square is constant, so therefore that is x square y we have to write, and here y square is there, integration of y square with respect to y is y cube by 3. So and limits are from y is equals to x to y is equals to root x into dx. Okay, so now in the next step I is equals to, now if you want you can take LCM and keep that 1 by 3 outside, otherwise you can keep there only, no problem. Yes, so if you want to take that 1 by 3 outside, then here I'll write that 1 by 3 out. Okay, that is because that is a constant, so x equals to 0 to x equals to 1, so this becomes 3x square y because of by taking LCM plus y cube, limits are from y is equals to x to y is equals to root x into dx. Next, which implies that I is equals to integration, 1 by 3 we have to write first, 1 by 3 integration x equals to 0 to x equals to 1. Now put a upper limit, that means wherever y is there you have to write y is equals to root x, then what you will get, 3x square root x, and here that is y is root x plus y is root x, so root x cube. Yes, next this is for upper limit, okay, this is for upper limit, minus for lower limit. Lower limit is what? Y is equals to x. So wherever y is there, we have to replace x. Then it becomes 3x square into x, next plus, that is instead of y we are writing x, so therefore it is x cube. Then here it is dx. That means I is equals to 1 by 3 integration from 0 to integration from x equals to 0 to x equals to 1. Now 3 into x square root x. Root x means what? 1 by 2. That means how will write 3 into x square plus 1 by 2. That means x to the power 2 plus 1 by 2. 2 plus 1 by 2 means, that is 2 plus 1 by 2 means 5 by 2. So therefore I'll write x to the power 5 by 3 into x to the power 5 by 2. And here this is root x means 1 by 2. So therefore it is x to the power 3 by 2 minus, it becomes 3 x cube, x square into x, x cube, minus of plus minus, this is x cube. Then now into dx. Again rewrite it, 1 by 3 integration from x equals to 0 to x equals to 1. This is 3 into x to the power 5 by 2 plus x to the power 3 by 2 minus 3x cube minus x cube. It becomes minus 4x cube into dx. Now integrated with respect to, that is x, 1 by 3. Okay, so 3 x raised to 5 by 2. What is the integration of this? Integration of this will be x to the power 5 by 2 plus 1 divided by 5 by 2 plus 1, and here 3 is there, you have to write as it is. Next plus x to the power 3 by 2 plus 1 divided by 3 by 2 plus 1 minus 4x to the power 4 divided by 4, and limit is from x equals to 0 to x equals to 1. This 4 get cancels, and now here I is equals to 1 by 3. You can see here this is 3 into x to the power, how much you will get? X to the power, if you take LCM, this is 2. Okay, 5 plus 2 7, 7 by 2. That means here it is 7 by 2, and here is also it is 7 by 2, plus here it will be 5 by 2 divided by, this is 5 by 2 minus x to the power 4. This is x equals to 0 to x equals to 1. So now I is equals to 1 by 3. You can keep it outside. Then now 2 will this 2 will comes to the what, that is numerator. 3 into 2, that is 6. This is 6 by 7. 6 by 7 into x to the power 7 by 2, plus here this 2 will comes here, that is 2 into x to the power 5 by 2 divided by, that is 5, and here it is x to the power 4. Now put upper and lower limit. For upper limit you will get I is equals to 1 by 3, here it is 6 by 7, x equals to 1. 1 to the power anything is what, that is 1 only, plus 2 by 5 into 1 minus 1, and for lower limit it will be 0, not to worry. Okay, so now so how much you will get by this? That is final answer is 3 by 35. Okay, so I'll write here I is equals to 3 by 35 is the final answer. Okay, so like this, so we can solve as many as examples you want on this double integration. Okay, so one more last example I would like to take, so that is very important. So therefore now I'll go for that particular example. Yes, so next problem number 3. So example number 3, evaluate double integration xy into dx dy over a positive quadrant of the circle x square plus y square is equals to a square. X square plus y square is equals to a square. X square plus y square is equals to a square. Okay. So now here limits are not given. Okay. No limits. No x equals to from something to something, y is equals to from some variable to some variable. Okay. They are not given. So now we need to see by this particular what, that is information. They said positive quadrant of a circle x square plus y square is equals to a square. What is that x square plus y square is equals to a square? It is a circle. It is a circle with the radius. It is a circle with radius, that is a. So this is a. Okay. So therefore this one we need to do. Now then this particular point is x equals to minus a to x equals to, that is plus a. Okay. That means what we have fixed, that is what we have fixed the limits along x axis, that is x equals to minus a to x equals to, that is plus a. Now we need to check along y axis. Okay. This is a lower curve and this is, that is upper curve. That means here we can write it like this, that is here it is there. Okay. And this is from this particular point to this particular point. Okay. So now what is the function of this particular lower curve and what is the function of this particular curve? Okay. Given is what, that given circle is, that is x square plus y square is equals to, that is a square. Okay. So if you rewrite that, here I'll write given circle is x square plus y square is equals to a square. Keep this y square here and send this x square to this side. Then what is y? Y is plus or minus square root of a square minus x square. That means plus or minus is that. See, y is negative in the what, that is downward direction from this particular, from x axis to downwards y is negative and from x axis to above that will be positive. So therefore here I'll write here this one I'll write y is equals to minus square root of, that is a square minus x square, and here for this particular function, that is y is equals to plus a square root of a square minus x square. Okay. So therefore from this particular curve to this particular curve, now we have fixed that's what the limits along x axis and along y axis. Along x axis, that is what, from x equals to 0 to x equals to a, and along y axis is from y is equals to 0 to y is equals to, that is a. But here they are said positive quadrant. They said that is positive quadrant. Positive quadrant means what? That is y is positive in the upper side. So therefore we have to restrict ourselves this particular curve with this line, because that is the positive quadrant. Okay. So y is positive in this upper part, not in the lower part. Lower part y is negative. Then what is the equation of this axis, x axis? That is, we can say that as, here I'll say this is y is equals to, that is 0. That means we are running from y is equals to 0 to y is equals to 0 to y is equals to square root of a square minus x square. Okay. So therefore next write down, let I is equals to double integration xy into dx into dy. That means I is equals to first fix x coordinate, x equals to minus a to x equals to plus a, and here y is equals to 0 to y is equals to this line to this line. That means y is equals to square root of a square minus x square into dy into dx, call it 1. So now start integration. That means, which implies that I is equals to x is from minus a to x equals to plus a, x equals to minus a to x equals to, that is plus a, they have said actually it is not from minus a to plus a, this is from, they said positive quadrant. Positive quadrant means only this much is a positive, because here x is also positive and y is also positive. Sorry for the inconvenience. This is not from x equals to minus a to x equals to plus a, it is x equals to 0 to. That means from this particular point we have to restrict ourselves. So therefore this is x equals to 0 to x equals to a. So therefore make it x equals to 0 to x equals to a, and here this is also x equals to 0 to x equals to a. Now we have to integrate this with respect to, here dx, here first it is dy into dx. Okay, with respect to y we have to integrate xy. So therefore x will be as it is, y becomes y square by 2, and this is from y is equals to 0 to y is equals to, that is square root of a square minus x square into, that is dx. So now I is equals to integration from x equals to 0 to x equals to a. Now put y value here, x into square root of a square minus x square, here 1 by 2 you can keep it outside, minus putting lower limit, that will be 0. Okay, so therefore into dx here we'll get. So I is equals to 1 by 2 integration from x equals to 0 to x equals to a, this is x into a square minus x square into dx, because square root and square get cancelled, these two. So therefore x into a square minus x square will get. So I is equals to 1 by 2 integration from x equals to 0 to x equals to a, x into a square, that is a square x into x square, that is minus x cube, because here negative sign is there, into dx. So I is equals to 1 by 2. So now integrate this with respect to, that is x, that is here you will get a into x square by 2 minus x raised to 4 by 4, because integration of x cube is x raised to 4 by 4, and integration of x is x square by 2, and the limits are from x equals to 0 to x equals to a. So therefore I is equals to 1 by 2. Now put x is equals to a, then here you will get, that is a into, that is a square by 2 minus a raised to 4 by 4 minus 0. So I is equals to 1 by 2, here it is a cube, here you will get, it is a square, here the square is there, so therefore it is a square. This is a raised to 4 by 2 minus a raised to 4 by 4, that means it is plus a raised to 4 by 4, that means a raised to 4 by 8 is the final answer. Okay, so like this we can solve as many as examples you want on this double integration. Even you can see few more examples in the other videos that I have already posted in the YouTube channel. Yes, so now after this I need to go for, that is triple integration. After this we need to go for, that is triple integration. We need to understand what do you mean by triple integration. Simple, very simple. Here whatever you have taken double integrations, okay, 2 integrations, like that we need to take, that is 3 integrations. One is along x-axis, that means one limit along x-axis, another limit along y-axis, and one more limit is along, that is z-axis. Okay, here in the triple integration all the three x's will come into the picture with the limits. Okay, so you can very easily understand in the single integration where only x will be varying from some value to some other value. Okay, and then in the double integration, okay, both x and y will vary. That means what, from some limit to some limit x will varies, and some limit to some limit y will varies, and in a similar way in the third integral even z will also vary from some function to some other function. Okay, so therefore now I'll start with the that is triple integration. Next is that is triple integration. Next is that is triple integration. Guys, I think in the double integration you will very easily understand that. So we have taken integration over a area A f of x comma y into dA vz. Okay. In a similar way, in the triple integration, so we'll take a integration not over a area A. So we'll take a integration over a region R f of x comma y comma z into, means you can say dr, or we can say it is dv. Okay, dv means what? That is volume element. Okay, so over a region R we will do this, and whatever this f of x comma y comma z is there, it is a function of x, y and z. Here in the double integration, it is only a function of what? That is x and y. Okay, but here it is a function of x, y and z. So therefore x will be in terms of what? That is x, y, z. So therefore, so we'll be defining it like this. So now here directly I'll write the equation. So how one can that's what write that triple integration form. So here you can see triple integration over a region R f of x comma y comma z dx dy dz. Or you can also write it as what? That is dz dy dx, or in any form. So which will be on which you will be comfortable. So here this is equal to, how will write integration. So first I have to what? Allocate the integration, that means sorry, limits of x, that means limits along the x axis. So we can say x equals to some x equals to a to some x equals to that is b. This is a constant. So in any reason you can fix, that's what, from where to where it is ranging in x axis, that one can very easily write, that is x equals to a to x equals to that is b, we can write. In the next integration we can write y is equals to y1 of y is equals to something y1 of x to y is equals to that is y2 of x. This is done. So you can see here x is constant, x is equals to a to x equals to b, so both are constant. Here y is not constant, y is a function of what? That is x. Y is a function of x from one function to another function, that means y1 to that is y2. You can see here y is equals to y2 of x. Similarly here z is also there, here z is also there, and z is a function of, you can see z is a function of two variables, one is x and the other one is y, and here also z is a function of z2 of x comma y. Okay, just you can see here x is constant, here y is a function of x, here z is a function of both x and y, and here it is f of x comma y comma z. Then how to write? Whether dx dy dz we can write, or something else? No, you cannot write dx dy dz. If you write here dx, then this is with respect to z. No, because limits are with respect to that is z, not with respect to x. So therefore here we need to write that is dz first, and here next is with respect to y. So therefore that is dy. Last one is with respect to x, so therefore it is that is dx. Okay. So this we can call that is triple integration over a region R. Region R is in a space. You can understand area is in the plane, but a region is in the space. If something comes under space means what? It will be having three coordinate system, that is x, y and z. So therefore that means it's a three-dimensional space. So now you can call it as what? That is equation 1. Okay, it is very important the form in the what? That is triple integration. So now we shall start examples directly on what? This triple integration. Okay, so examples. First example is first example. Yes, evaluate integration 0 to 2, integration 1 to z, integration 0 to yz, x, y, z, dx, dx dy dz. See, here it is dz dy dx, but here it is dx dy dz. That means this third integration sign, whatever there, that is with respect to x. That means x equals to 0 to x equals to yz. Next, this is with respect to y. That is y is equals to 1 to y is equals to z. And the last one is, that is z is equals to 0 to z is equals to 2. So this can one can very easily understand this particular form. So now I'll rewrite it. Solution: let I is equals to integration 0 to 2, I is equals to integration 1 to z, integration 0 to yz. This is x y z dx dy dz. Okay, what is this x y z? This is f of x comma y comma z. So therefore you can see x y z is a function of what? X y z. So this is f of x comma y comma z, right? So now write the limits. This is first integration whatever there, so that will be for this last variable. That means we have to write z is equals to 0 to z is equals to 2. Next, the second one is for this second. Okay, this is for second. So therefore y is equals to 1 to y is equals to z, and this third one is, that is for this dx. So therefore x equals to 0 to x equals to yz, x yz dx dy dz. And now we can call it as equation number 1. So first you integrate this with respect to what? That is x. So if you integrate that with respect to x, means what? We have to keep first two integrals as it is. That is z is equals to 0 to z is equals to 2, y is equals to 1 to y is equals to z. Okay, we have to keep as it is. Now we need to differentiate this function with respect to x. If you differentiate this with respect to x, then y and z will be treated as constant. So therefore keep y and z as it is. Integration of x is x square by 2. So therefore it is x square yz divided by 2, and limit is from x equals to 0 to x equals to yz into dy into dz. Okay, next I is equals to integration from z is equals to 0 to, that is z is equals to 2. Here whatever 1 by 2 is there, you can keep it outside also if you want, because it's a constant. Okay, so you can, if you want, you can keep it outside. So I'll keep it outside, that is better. So 1 by 2 integration from z is equals to 0 to z is equals to 2, integration from y is equals to 1 to y is equals to z. So now here this is x square yz is there. Okay, instead of what x we need to find, that is we need to put x equals to yz. So therefore yz square into yz. This is for upper limit, and for lower limit it is 0, because x is 0 means what? Whole term is 0. So therefore you can write 0. Yes. So this is dy, this is dz. Next, I is equals to 1 by 2 integration from z is equals to 0 to z is equals to 2, and here it is integration from y is equals to 1 to y is equals to z. This is, you can see, y square z square y z, that means y cube z cube will get. Okay, y cube z cube into dy into dz. Now integrate it with respect to what? That is with respect to y. So I is equals to 1 by 2. First integration you have to keep as it is. Z is equals to 0 to z is equals to 2, you have to keep as it is. Now integrate this with respect to y. That means z cube will be constant. Keep it as it is. But integration of y cube is y raised to 4 by 4. Y z cube by 4, and this will be from y is equals to 1 to y is equals to z into dy, into dz. Only one remains, okay, because already I integrated with respect to y. So now I is equals to 1 by 4, you can take it outside because that is constant. Yes. So now integration from z is equals to 0 to z is equals to, that is 2. Now y will be replaced by z. So therefore z raised to 4 into z cube minus y will be 1. 1 raised to 4 into z cube into dz. That means I is equals to 1 by 2 into 1 by 4, 2 into 4 8, 1 by 8 we can write integration from z is equals to 0 to z is equals to 2. This is z raised to 7 because z raised to 4 into z raised to 3, z raised to 4 plus 3, that is z raised to 7 minus 1 raised to 4 is 1, so therefore it is z cube only into dz. Now differentiate this with respect to what that is z. Z raised to 7 becomes z raised to 8 by 8, z raised to 3 becomes z raised to 4 by 4, and it is z is equals to 0 to z is equals to 2. Okay, so you can directly put upper limit and you can simplify it, otherwise you can take 8 as that is LCM. So 1 I is equals to 1 by 8. If you take LCM here, this will be again one more 1 by 8 will come, so this is z raised to 8, this is minus 2 times z raised to 4, this is z is equals to 0 to z is equals to 2. Now I is equals to 1 by 8 into 1 by 8, 1 by 64, 1 by 64, put upper limit, that is z raised to 2 raised to 8 minus 2 into 2 raised to 4, and for a lower limit it will be 0, write 0. So I is equals to 1 by 64, 2 raised to 8. Instead of that we can take 2 raised to 4 common. Yes, we can take 2 raised to 4 common, then here you will get 2 raised to 4 minus this is 2. 2 raised to 5 we can take because okay, no problem. Then I is equals to 1 by 64 into 2 raised to 4 is 16 into 16 minus 2. That means I is equals to 1 by 64 into 16 into 14. So 16 ones are 16 fours are. So I is equals to yes 14 by 4. That means I is equals to 2 sevens are 2 twos are. This is 7 by 2. So the final answer is that is 7 by 2. Yes, the final answer is 7 by 2 for the first example. Okay, so like this we can solve many examples. So next I will consider one more example. Yes, okay, so we shall see one more example, okay, which will be very useful. Okay, so evaluate example number 2, evaluate integration 0 to 1 integration y square to 1 integration 0 to 1 minus x into dz dx dy. Okay, you can see the order how they have given. In that order only you have to write, you have to allocate, that is the limits. Let I is equals to, directly I'll write. So here for this first is this last the variable, so therefore we need to write y is for the first integral y is equals to 0 to y is equals to 1, and for the second this one will come, that means x equals to y square to x equals to 1, and for this third with respect to z is there, so therefore z is equals to 0 to z is equals to 1 minus x into dz dx dy. Call it equation 1. Okay, so now integrate it. First you keep first two integrals as it is, y is equals to 0 to y is equals to 1, x equals to y square to x equals to 1, and here x we are integrating x with respect to what, that is x with respect to z, so therefore x is kept constant, and constant means what, x into z will get, that means integration of 1 is z with respect to z, so therefore z is equals to 0 to z is equals to 1 minus x into dx into dy. So now I is equals to integration from y is equals to 0 to 2 minutes. Y is equals to 0 to y is equals to 1. Integration from x equals to y square to x equals to 1. Now put upper and lower limit. X into 1 minus x, and for lower limit it will be 0 into dx into dy. So I is equals to integration from y is equals to 0 to y is equals to 1. So now this is integration from x equals to y square to x equals to 1. X into 1, that is x, x into x square, x into x, that is x square, into dx into dy. Now integrate with respect to x. So therefore first integration is as it is. Integration of x with respect to x is x square by 2. Integration of x square is x cube by 3 into dy. And the limits are from x equals to y square to x equals to 1. So I is equals to integration from y is equals to 0 to y is equals to 1. For upper limit it will be x is 1, 1 by 2 minus 1 by 3 minus, this is, if you put x equals to y square, then y square is y raised to 4 by 2 minus, here it is y raised to 6 by 3 into, that is dy. So I is equals to integration from y is equals to 0 to y is equals to 1. So this is actually 1 by 6 is what, that is LCM. So therefore here you will get 3 minus 2 by 6. Here it will be this is 3y raised to 4 minus 2y raised to 6 divided by 6. So into dy. So 1 by 6 can be taken it outside. So 1 by 6 you can write it outside. Then integration from y is equals to 0 to y is equals to 1. 3 minus 2, it is 1. 1 minus 3y raised to 4 minus of minus plus 2y raised to 6 into dy. So therefore I is equals to 1 by 6. With respect to y we have to integrate. That is, here we will get y minus 3y raised to 5 by 5 plus 2y raised to 7 by 7. So y is equals to 0 to y is equals to 1. Therefore I is equals to 1 by 6 in the bracket 1 minus 3 by 5 plus 2 by 7 minus 0. So the final answer is, therefore the final answer here is 1 minus 3 by 2. Yes, it is. I is equals to 4 by, that is 35. Okay, you can do it by using calculator also. Yes. So this is the second example. Okay. So remaining example you can do. 2 more examples are there. So very similar with the previous 2 examples. You can very easily understand those 2 examples. You can do it. In the next class we shall start change of order. Yes. Thank you.